Equations and identities. An equation is created when two expressions are set equal to one another such that they are equal for some values of their variables, but not for all. If they are equal for all values of their variables, then that is an identity, not an equation. So not all mathematical statements which include an equal sign are equations. Some are identities. An equation is created when two expressions are set equal to one another such that they are equal for some values of their variables, but not for all. If they are equal for all values of their variables, then that is an identity, not an equation. So not all mathematical. Here are some equations. S equals 15 over t, v equals 12 minus 9.8t, and x equals 10 plus 6t minus 4.9t squared. In all of these cases, the variables are interdependent. They are only true for certain sets of variables. Changing the value of t on the right side of the equation changes the possible values of s, v, or x on the left side, and vice versa. These are equations, not identities, since knowing the value of one variable changes the possible value or values of the others. Above are simplified physics equations in which t represents time, s represents speed, v is for final velocity, and x is for final position. In these equations, we have only two variables. In later math courses, there will be more than two. For instance, here are more general versions of those same equations. S equals d over t, or speed equals distance over time. Final velocity equals initial velocity plus at, acceleration times time. Final position equals initial position plus initial velocity times time plus 1/2 acceleration times time squared. In these cases, there are up to 5 variables, all of which depend on each other. It's important to see that equations define the relationship between variables, since the equation is only true for certain sets of values. Let's use this table to find some solutions to the equation speed equals distance over time, where s represents speed in meters per second, d represents distance in meters, and t represents time in seconds. We've entered the distance traveled and the time it took to travel that distance in 2 of the columns. Use the equation s equals d over t to find the speeds and fill in the blank column. So what's 30 divided by 2? D over t, 30 over 2, is 15. Alright, so if you go ahead and fill them all out, you see the first 3 rows, the speed was 15 meters per second. The final 3 rows, the speed was 60 meters per second. Note that in the first 3 sets of answers, the object was moving at a speed of 15 meters per second. The final 3 sets of answers are for an object traveling 4 times faster, at 60 meters per second. But in all of the cases, knowing the value of 2 of the 3 variables determines the values of the third. Knowing any 2 of the values determines the third. Try it in this case, where the equation is still s equals d over t, but the values of different variables are provided. Can you still figure out the unknown values and complete the table? Alright, well, let's go through it. S equals d over t. If we're looking for s, we just divide distance by time. 20 by 2 is 10. Alright, but here, we know the speed is 20. 20. And we know that must be equal to d, which we're looking for, over t. So, and t is, we have t. T is 5. So what divided by 5 is equal to 20? Okay, well 100 divided by 5 is equal to 20. Here we know speed is 10, and we know the distance is 100. So therefore, what must the time be? So if something is moving at 10 meters per second, how long will it take that object to travel 100 meters? Well, it would take 10 seconds. 10 meters a second for 10 seconds, we would go 100 meters. So we can continue solving that way. This was more challenging since this equation is solved for speed, not for distance or time. Filling in values will be even more challenging when we work with equations that have more variables. We need a way to solve an equation for any variable so that we can find its value given the values of the others. Solving an equation for a variable means to get it alone on the left side of the equation.